Alright, now for the grand culminating event, acid and base titrations. So this unit, this is the one that you hear everyone complain about from last year and previous years. Acid-bases titrations, what makes them tricky is there are several calculations that occur during acid-base calculations, or acid-base titration calculations. So we're actually going to use pieces from almost every lecture previous to this one in the acid-base calculations. So anytime I say something about buffers or about weak acids, Ka, Kb, your best bet is to look back to the previous videos, refresh yourself, and then try and catch up on this. But it's important that you understand all the stuff in the previous lectures before you get too far into acid-base titrations. So why do we do acid-base titrations? Titrations are actually a quantitative lab problem, which means quantitative, you counting things, you're figuring out how much there is. So what you do is you have an unknown acid or base, and then you add a known acid or base to it in order to figure out what the pH is, what the H plus concentration is. And you do this by adding until you get to the equivalence point. So the equivalence point is the point when you have equal amounts of acid and base. So what that means, equivalence point, is that H plus, the concentration of H plus, equals the concentration of OH minus. However, the equivalence point is not the same thing as neutral. Alright, this does not mean that the pH equals 7. So the reason for this is because when this happens, we get in those conjugate acids, conjugate bases from the weak acids to produce those salts. We create a buffer, and the pH is not always going to equal 7. It will if you have a strong acid, strong base titration, but anytime you're using a weak acid or a weak base in a titration, your pH will not equal 7. Okay, you indicate, you know that you're at your equivalence point, your end point, based upon usually indicators. Okay, so you use an indicator color change, and we'll talk about the different indicators later. So the basic process for a titration then, let's say we have an unknown acid. So we've got an acid that has a number of moles of H plus. So we have an unknown number of moles of H plus. And it's sitting here in a beaker. And we want to figure out what the concentration of H plus is inside there. So we don't know how many H pluses are inside of that solution. What do we do then? We add in a known amount of OH minuses. We do this by using a burette that will drip in the hydroxide one step at a time, or one bit at a time, so that we can very, very precisely add a certain amount of OH minuses. So at the equivalence point, the H plus concentration will equal the OH minus concentration, or the moles of H plus will equal the moles of OH minus. So what we're doing with the titration then is we're adding in a known number of moles of OH minus. So what that means is if we know this number right here, for this particular titration, if we know how many moles of hydroxide we have added to get to the equivalence point, then we're going to know how many H pluses were in the initial solution. So we count how many of these we add, that's going to equal this guy, and so we could trace that back to figure out how many H pluses we started with. And it's going to be different for different kinds of acids and bases. You can flop this too. You can have an unknown base, and you can add in a known amount of H plus, and then the same thing, you would know how many H pluses you added, so you could figure out how many hydroxides were in that initial solution. This is a very standard lab practice. Anytime you guys take a Q-Chem lab in college, you're going to have to do a titration. Use it very, very often to find unknown concentrations of acids. There's lots of different titrations you can do. You can do redox titrations as well, but acid and base titrations are the most common. Okay, so there's 3 types of acid-base titrations. The most easy would be your strong acid to strong base titration. And when you do that strong acid, strong base, it can be a strong base, strong acid too. It doesn't really matter. So, I mean, you could flop those. You can either titrate a strong base with a strong acid, or you could titrate a strong acid with a strong base. It's just whoever's where. The one thing that makes the pH of the strong acid, strong base titration so much easier is that at equivalence, the pH will equal 7. Okay, at the equivalence. That spells equivalence. So pH equals 7 at the equivalence point for strong acid, strong base. For the titration of a weak acid with a strong base, though, the pH will not equal 7 at equivalence. More often than not, it won't. And for a weak base or with a strong acid, the pH will also not equal 7 at equivalence. And we'll talk about what the pH will equal for those different versions of titrations. But the key is for this one, pH should equal 7 at the equivalence point, but for these two, it shouldn't equal 7 at the equivalence point. And we don't do weak acid, weak base titrations because it would be really, really tricky to do any calculations. And the point of these is to figure out an unknown concentration. It's not just to have fun with chemicals. And so to use these two to titrate each other, you're not going to get very accurate numbers at the end, so why bother?